Hello everyone. In our last classes, I actually couldn't do the record of this particular day. Okay, so in this day, I'm re-recording this portion of this subject so that you can access it via YouTube. Okay, so let us start. Here we were discussing about sewer materials. Okay, sewer materials. So, whenever we are considering any kind of sewers, obviously we have to build it with the help of some materials. Okay. So, while considering those materials, there are various properties we require to check whether those materials are good or bad, or can it be useful for our specific sewer requirements. Okay, sewer specific requirements. So is it applicable or useful? That is why these factors are considered. Okay. So what are these factors? So any material by which we will construct a sewer must be resistant to corrosion. Obviously, in the sewer there might be various kind of chemicals, various kind of acidic and basic nature, alkalinic nature material which will corrode the surface of the inner surface of the uh, sewer depending on the material. That is why while considering the material, we must also consider what kind of sewage is flowing through that material, and will that sewage has the ability to corrode the inside of the specific sewer material that we will be considering. Okay. Similarly, we have to consider the inner surface must be resistant to abrasion. The second point, abrasion. Obviously, in sewage, there will be various kind of solid particles. Okay, those solid particles will be sliding, rolling, or floating on the sewage. Okay, those particles actually give a impact at the inside of the sewer surface, and that is when abrasion will happen. Okay, so our material must be resistant to those kind of abrasion. Okay, strength and durability. Okay, we know durability is important because as we are considering a sewer line for at least 30 to 15 to 30 years. Okay, so it must be durable so that at those lifetime it can properly cover. Okay, another thing is strength. Generally sewer pipes are built underground. Okay, so various kind of loads may come on those sewers. Okay, earth pressure, earth pressure, then again sewer pressure, that will be hoop stress on the side of the perimeter of the sewer. Okay, another thing, as it will be underground or slightly underground, there will be various kind of loads that will be placed on the sewer lines. Okay, so the sewer pipes or the material by which we are constructing a sewer must have enough strength to support those loads. Okay. Next, we are considering weight of the material. Obviously, if the material is, if we consider weight of the material, if the material is very much heavy, okay, then it will be our problem. It will be our problem because a heavy material we cannot use a heavy material. Okay, so we cannot properly. What do we say, we cannot properly handle heavy material. Okay, so that is why we consider the sewer pipe must be of less weight. Okay, next, imperviousness is very much required. Impervious is required because if we do not provide impervious material, the flow from sewer may get inside the groundwater, or groundwater may percolate into the sewer pipes. If sewer pipe, the flow from sewer goes outside the sewer pipes and enters groundwater, then our groundwater will be polluted. Again, if groundwater continuously seeps inside the sewer pipes, then the treatment facility of those sewer, okay, the load on the treatment facility will be high. Next, cost. Cost is very important. We want it to be cost effective. Okay. Next comes hydraulic efficiency. Okay, this is an important thing when we are considering design of a sewer pipe. Okay, so hydraulic efficiency is important because we want the sewer pipes to have self-cleansing velocity. Okay, without a proper hydraulic efficiency, self-cleansing velocity cannot be retained for small flow or low lower flow value. Okay, if our flow is less, then our shape of the sewer should be such constructed that it has sufficient hydraulic efficiency so that self-cleansing velocity can occur and the particles that is present in the sewer can be completely cleaned off. Okay, so these are the requirements for the materials. But what are the materials we actually use? Okay, first we are considering here, we are considering asbestos cement sewer. Okay, so asbestos cement sewers are generally relatively flexible. Okay, these are generally made up of 10 to 100 centimeter dia internal and are of 4 meter in length. Okay, it is relatively flexible and it can be bent about 120 degree. Okay, so again it is lightweight. It is lightweight. Okay, that is like easy to handle. Okay, easy to cut. Obviously easy to handle and easy to construct. Okay, easy to cut. Okay, again excellent hydraulic efficiency. Okay, the n value is very less, that is why it can provide a better flow of the sewage. The problem with asbestos cement sewer is it is not very strong. We cannot place any kind of load. Okay, susceptible to corrosion by H2SO4. We cannot provide it in acidic sewer. Okay, if sewage is acidic, we cannot provide asbestos cement sewer. Next comes plain concrete cement or reinforced cement concrete. Plain cement concrete or reinforced cement concrete. Okay, we know these are generally strong materials. Okay, so they are strong both tension and compression. Their resistance to erosion and abrasion, okay, can be made of any required strength because we just have to change the proportion of the cement and other materials so that we can build a stronger uh, sewage. Okay, so that the strength can be variable and according to requirement we can make those uh, pipes stronger. Okay, again it is easy to make, it is economical, available in various shape and size because it can be made in on the site itself, but actually it can be made of various shape and size because we have to cast it according to the shape and size, and it is very much resistant to erosion and abrasion. Okay, problem is it can be corroded by H2SO4, cannot use in acidic environment. Okay, carrying capacity um, uh, capacity reduces over time due to corrosion. Okay, obviously this is the effect of corrosion. Okay, those are the disadvantages. Next come vitrified clay or stoneware sewer. Okay, they are heavy. Okay, because they are made up of stone. Okay, so what are the importance here? What are the advantages? Corrosion resistance. They can resist corrosion. Okay, hydraulically efficient flow will be better. Okay, highly impervious. So we will not get any kind of seepage from or towards the groundwater. Okay, strong in compression. Okay, so it can be laid underground so that compressive load, it can take compressive load. Okay, and it is durable. Obviously those are made up of stone and vitrified clay, those are durable generally. Okay, again disadvantages, they are heavy and bulky. Obviously they are made very thick. Okay, so that they can take the load. Weak in tension, these materials are weak in tension, that is why we cannot provide it in those areas where there may be any kind of tension on the sewer line. Okay, small in length, obviously those are made up of clay and sand, clay and stone, that is why we will not get longer pipes. Okay, and that is why because it is so short in length, That is why it requires large number of joints. Those are disadvantages. Okay. Next, we come to brick sewer. Okay, brick sewers are generally designed for stormwater drain and large size sewer. Okay, if two or three sewers are connected at a point, we can provide brick sewer so that it can take the sewer from all those uh, branch sewer pipes. Okay. Similarly, we have cast iron sewer. Those are strong in tension. Okay, can be used as pressure pipe. Okay, generally whenever there is involvement of pump in sewer pipes, we have to use cast iron sewer. Okay, it is generally used in outfall sewer. That means during disposal, rising main, it is connected with pump. Okay, inverted siphon. Inverted siphons are generally under pressure because they run in full capacity and um, they have a pressure higher than atmospheric pressure. Okay, but problem is they are very costly. Next comes steel pipe sewer. Okay, so in steel pipe sewer, it can be used as pressure sewer. Okay, water crossing as we have seen in inverted siphon. Railway crossing we can provide steel pipe. Okay, they are more ductile than cast iron pipes. Okay, that is why they can be easily bent. Okay, and the problem is they are costly. Okay, next come PVC pipe. PVC pipe. Okay, these are mostly used in household purposes. Okay, so that is why used in drainage, internal drainage system, smooth internal surface, lightweight, resistance to corrosion, and economy. Okay, it can be used, but it doesn't have higher strength. Okay, it can take much load. Okay, then comes glass fiber reinforced plastic pipe. Those are plastic pipe but reinforced with glass fiber. That is why they are strong. Okay, they have high tensile strength so that they can be used with pumps. Okay, uh, they are light in weight and they are corrosion resistance. Okay, lastly we consider lead sewers. Okay, those are smooth and soft. Okay, that is why they can be easily constructed. Okay, they are corrosion resistance, mainly H2SO4 corrosion it can resist. Okay, so it can be used in acidic environment. Okay, very costly and not very strong. Okay, it is soft but not very strong, so it can't take load and it is very costly. Okay, so these are the points. Next, these are the types of sewer material we have considered. Let us consider the various shapes of sewer materials. Okay, let us start from here. So here we are considering shape of sewer pipes. These are the various types of shapes we are considering. Okay, standard egg shaped and new egg shaped. These two are standard and new egg shaped. Okay, again we have horseshoe shaped. Okay, this is a horseshoe shaped section. Parabolic section, you can see parabolic section. Okay, semi-elliptical, rectangular, U-shaped, semicircular, basket handle shaped sphere. Okay, um, okay, these names generally used for various kinds of shape of the sewer. And now the question is why different kind of shape we have considering. Okay, so these sewers generally has different kind of perimeter with respect to their cross-sectional area. That is why considering various kind of various flow. Okay, if we consider flow that is for combined sewer, then we use generally standard egg-shaped and new egg-shaped pipe. Why we use this? Because during combined system, the variation of flow is higher. Okay, at lower at when there the discharge will be low, only DWF will work. Okay, then what will happen? This portion will be filled up, and at this portion, the DWF will flow will have also a relatively lesser perimeter. if we consider a circular pipe. Okay, so compared to an equivalent circular pipe, a standard egg or modified egg-shaped sewer will have higher hydraulic efficiency at low discharge. Okay, that is why while considering combined system, we use these two type of sewer. Okay, because the variation is higher here. Okay, again horseshoe shape parabolic and semi-elliptical, those are used for large sewer system. Okay, so horseshoe, parabolic, semi-elliptical, even semicircular pipes also used for large sewer pipes. Okay, so those have heavy discharge. Okay, in general, during the disposal or in main sewer, we can use these kind of shapes. Okay, again then come rectangular rectangulars, generally those rectangular sewers are used for storm water. Okay, because storm water carries lesser material particles. Okay, uh, that is why those can be flowed through rectangular sewer. Again, U-shaped sewer is also used for large sewers. Those have a higher discharge. You can use U-shaped sewers. Okay. So these are the types of sewer. Basket handle shaped sewer generally, mm, actually it is very rare to see. So we don't have those kind of specific use of this basket handle shaped sewer. Okay. So these are the types of sewer. Okay, sewer pipes. Next, we are considering sewer appurtenances. Okay, so this is a bigger chapter, sewer appurtenances. Okay, so whatever things we consider while considering a sewerage system. Okay, so those are important part of a sewerage system. Okay, so in this sewerage system, we have manhole, lamp hole, clean outs, street inlets called gullies, catch basin, inverted siphon, etc. So let us discuss one by one. First, let us discuss about inlets. First, let us discuss about inlets. Okay, so inlets. What inlets do actually? It actually admits storm water to the combined sewer or storm sewer. But while admitting, it also has to check from where it have to admit those uh, rainwater. Obviously, uh, it will be placed at the lower depressed area from which we are trying to drain out the rainwater. Okay, generally they are of three types according to the direction of the inlet grills. Okay, there will be various grills so that big particles doesn't go inside. Okay, so according to the direction of the inlet grills, we will have various kind of inlets. Those are curved inlets. They are vertical. Their grills will be vertically placed and they are placed on a curve like here, so that the rain on the road can easily enter to the combine or storm sewer. Again, gutter inlet or horizontal inlet, they are generally placed in a depressed area like this. Okay, and level of this portion will be at the most lowest position. Okay, it will have the most lowest position, lowest level of this area, so that the rain water at this area comes into this inlet and goes inside. Okay, so it is called gutter inlet or horizontal inlet. You can see those grills are placed horizontally. Again, we have combination inlet, yeah, combined inlet. In this, we provide a gutter inlet and a curved inlet together. In general, curve or inside in roadsides, we generally provide this kind of combination inlet. Okay. Generally, they are spaced at 30 meter apart in straight road. Okay. So these are our inlets. Next come catch basin. So inlets will lead you to catch basins. Catch basins generally catches the particulates that will flow inside the sewer with stormwater. So if we let most of the solid particles go through the sewer pipes, our treatment facility will be much more harder. Okay, so that is why what we consider those particles to stay at those basins. Okay, so whenever there will be rain, water will come inside these basins. Okay, solid particles they will carry with them, will settle at the bottom, and as the level gets higher, the water will go out through the outlet after those particles get settled. Okay, so that is why it is called a catch basin. It catches the particles, okay, that we don't want in our sewer lines. Okay, next comes cleanouts. So cleanouts are inclined connected pipes, okay, to the main sewer. This is the main sewer, this is main sewer. Okay, this is inclined connection and this is the ground level. Okay, so we are considering a inclined pipe starting from ground level reaching main sewer. Why generally we provide this kind of clean outs? Generally what happen in main sewer, in some points there may be accumulation of solid particles. This accumulation will lead to will clog the whole main sewer. That is why if we know where the clog is actually present, we can open the clean out pipes and we may use some kind of flexible rod to push it. Okay, or we may use some kind of water pump and uh, at a high pressure we can release water through these cleanouts. Okay, if we send water at a high pressure through this cleanout, what will happen? Water will come and push these uh, particles, okay, through the main sewer, okay, and thus the clog will be open. Okay. So these are our cleanouts. Okay, they are used in place of manhole sometimes. Okay, so these are our cleanouts. Next comes manhole. Okay, so manhole is the important chapter part. Okay, manholes are generally masonry structure. They generally provide access to the sewer pipe so that we can inspect, we can maintain those sewer pipes. Okay, so in general, those are placed in straight sewer lines also. Okay, and whenever there is any connection of two or three pipes, okay, branch sewer connecting main sewer or two branch sewer connecting together, or any kind of change in gradient. Okay, and if there is any kind of change in direction, we are providing manholes because at those places our solid particle may get stuck. Okay, and that is why we have to properly um, clean those points. Okay, and we have to provide a structure that is called manhole. Okay, generally manhole spacing dependent upon sewer pipes. Okay, so larger the sewer pipes, the greater the spacing. Okay, because larger the sewer pipes, there is the lesser chances of accumulation of solid particles. That is why we have a greater spacing of manhole. Okay, so classification of manhole, if you consider classifications, there are three types of manholes according to their size: shallow manhole, normal, and deep manhole. Okay, so deep manhole are those which are larger than 1.5 meter deep. Okay, normal manhole is 1.5 meter deep, and shallow manholes are 0.7 to 0.9 meter. Okay, so as I already told, every bend, junction, change in gradient, change in diameter, we have to provide manhole. Okay. So what are the various components of manhole? There are access shaft. Okay, let us go to this one. Okay, this is the access shaft. Access shaft means through which a person will enter. Okay, then he will enter through the ladders or steps provided here. Okay, so through this area he will enter, and this area is known as access shaft. Okay, it is called access shaft. This portion is known as access shaft. Okay, this is access shaft. Again, after accessing the through access shaft, the person will come inside. Okay, so here we will have some kind of walls. Okay, side walls. We will have side walls. These are branch sewers, okay, branch sewers, and this is main sewer, okay. And there will be a bottom that will be inverted bottom, and it is called benching, okay. So these are the components of a large manhole, okay. Similarly, we have lamp holes. Lamp holes are those where we cannot provide manholes. That is why we provide as a simple shaft through which we can enter a light, so that if there is any kind of blockage in the sewer pipe, we can detect it from the adjacent manhole. Okay. Again, if there is any kind of blockage, we can put high pressure water through this lamp hole also and clean the blockage. Okay. Again, there will be various kind of gases that will be those gases will be produced in the sewer lines. Okay, those gases can easily go out through these lamp holes. Okay, so this is the lamp hole. Next comes inverted siphon. Inverted siphon is a device so that we can provide crossing. Okay, whenever there is a crossing and we have to provide the pipe below ground level, okay, then we are providing inverted siphon. It is generally provided when there is a change in level. We have to mandatorily change the level of the sewer lines, okay. So a inverted siphon is a pressure pipe because the flow through it is under pressure higher than atmospheric pressure, okay. So generally, to cross some restriction, we provide inverted siphons. So these are the various kind of sewer appurtenances that we have to provide in the sewer lines. Okay, we will have different sewer appurtenances for domestic sewer lines. Okay, domestic sewer management. Okay, that we will be discussing afterward. So this is the portion that I already have taught you, but today I am just recording it because that day I missed the recording. Okay, I think everyone has understood all those points. Okay, if you have any kind of problems, any kind of queries, please don't hesitate to call me or don't hesitate to WhatsApp me those problems. Okay, thank you everyone. We will be discussing our last two classes in next videos.